absolute value. A new function today. You have a bunch of functions that you know. You may not even realize how many functions you know. And this afternoon, I will review all the functions you're supposed to sort of know at this point. So you'll know what the list looks like for the upcoming test. For now, I got to add one more function. The good news is it's a pretty nice function to deal with. And you might halfway through think it's the easiest function you've seen so far, but it has a little quirk to it, and I'll get to that little quirk, okay? Absolute value is simply the distance that a number is from 0. When you're confused about absolute value, when you're like, well, I don't even know what absolute value is, I can't figure this question out, go back to this sentence. This is the most important sentence about absolute value. When you want to know what absolute value is, you're just talking about how far from the middle you are. You can imagine a situation where you don't really care what side someone's on, left or right of something. You just want to know how far away they are. Go back to my stupid English Scottish war example. When someone's firing arrows, they don't care how far away is somebody. They don't care if they're left or right. They just need to know how far away someone is. That's what absolute value is. How far from the middle are you? So the absolute value of a number is always positive. We always talk about how far it is away. So if I'm standing here in the middle at 0, how far is 5? For you, how far is -5 for me? It's 5 away. How far is 5 for me? It's 5 away. You see how an absolute value makes everything positive. And we use this new notation. It might not even look like notation. You just put 2 lines around it, and that's absolute value. That's what you've come up with, is 2 little lines to show absolute value. And the answer is yeah. Think about this one. This is the funny one. All right, y equals root x over here. When you first see this in grade 7 or 8 or 9, when you first see it, so you just put a little check mark around it, and that means undo square. And the answer is yeah, pretty nice once you get used to it. So you have to get used to this one, that 2 little straight lines around a number means let's take its absolute value. Let's find out how far that number is from 0. Some examples, some easy examples to start off with. Absolute value has different levels of difficulty. These are the type of ones that hopefully are pretty straightforward, and there could be questions sort of like this on the test. You'll see in the homework where you have to incorporate absolute value. If you want to find the absolute value of 7, when you're first starting these, just ask yourself, how far is 7 from 0? It's 7 from 0. Hopefully you're unimpressed. You're like, this function is a bit of a joke, isn't it? It heats up, okay? We're just introducing it right now. Absolute value of -5. How far is -5 from 0? It's 5 from 0. It's 5 spots from 0. And by now you might have already built a rule into your head. I got absolute value. I totally get it. If it's positive, it's just the same number. If it's negative, switch it to positive. It's a pretty good rule. I'll tell you, it's a pretty good rule. It's not perfect. Sometimes you got to go back, and I'll keep saying it. How far is it from 0? I'll keep saying it like that so you get ready for tougher problems. Okay, I don't want to just lean on this rule. Positive's positive, negative's positive. There's a little bit more to it than that. And this is the first challenging one that comes up. Because your brain now might be screaming, hey, if it's absolute value, it's positive. That's all I got to remember. And that is true. The absolute value of something, that part becomes positive. But this question's got a negative in front of all that. So the way to evaluate this is you go, okay, absolute value of -43 is positive 43, but I've still got this negative out here, so it goes back to -43. And hopefully that example is enough to go, ooh, just got to be careful a little bit here. Yes, whatever's in the absolute values just becomes positive. That's true. But then anything else that's going on outside still does its own thing, sort of in a bedmass type of way. We've got to multiply everything still by -1 when it's all done. So 2 different functions going on here. One is take the absolute value, and second is then take your answer and multiply by -1. You get that bedmass feel going on now where it's like multiple steps you have to do. Any questions about those introductory examples to absolute value? More time? Were you able to find this note okay? It's in the right order? Everything's good? I made a new PDF this year, so I want to make sure everything's in the right order. Okay, we'll just heat things up a little bit. Absolute value, these things are often called absolute value brackets. They actually work the same as other brackets, and they fit into all the thinking from before as brackets. So they fit into bedmass like that. And what bedmass says is first evaluate what's inside the brackets, then move your way out. So I'm trying to fit it into that bed mass thinking that you had before. So absolute value doesn't work like this, where you just can take the absolute value of the individual pieces. There are functions that do work like that, where you can just distribute the function out front onto other pieces. Imagine this one, 3 bracket x plus 2. We can just take the function on the outside, and we've learned that you can just go ahead and do that. That on that particular function, you're allowed to multiply the 3 by each thing inside. Absolute value doesn't work like that. It does not work like that. That rule is not allowed over here. See, some rules work for some functions, and they don't work for other functions. This one, you have to evaluate what's inside first. Negative 12 plus 4 is negative 8. Then you can take the absolute value. So you've got to evaluate what's inside first. No easy way to take the absolute value of individual things. I don't have another trick up my sleeve and go, okay, now let me show you how to take absolute value of each individual part inside. No, that's not available to us for absolute value. Do what's in the brackets first, and then take its absolute value. And this last part is true. Absolute value of negative 8 is positive 8. This question I'm about to do every year is one of the worst ones done on the test. So I hope that gets your full attention. If you're drifting off to sleep, then you come back and go, okay, let me check this out. And even if you don't understand everything I say next, you should definitely put a highlighter on this thing going, okay, he made a big deal about that in the note. When I go to do these questions, I can't just gloss over them. I can't just ask my buddy and say, okay, what did you get for number 7D? Copy down their answer and think it's going to be okay. It's not going to be okay. We have to get this. We have to really understand what's going on here. First, let's just talk about number lines and what appears on number lines for a second so that we can move forward to putting absolute value on the number line. We really have to get this. For domain and range reasons, for key properties, that lesson later today reasons, for chapters 3 and 4, we really need to be able to go, okay, I know when you say x greater than or equal to negative 3, I know exactly what you're talking about. Let's talk about some numbers. Before we try and deal with the number line, let's talk about some numbers. My question. I always start with 0, because 0 to me is the easiest number to deal with in a lot of situations. Is 0 greater than or equal to negative 3? Does it fit in that category? Yes. So when I go to graph over here, the numbers that are greater than or equal to negative 3, 0 is in. And when you're really confused, you can just do it one number at a time. You know, just let me just take each individual number. So when I'm done this graph, 0 will be on there. So let's just do a neighboring point. Is 1 greater than or equal to negative 3? Yeah, 1's bigger than negative 3. 2's bigger than negative 3. 3. These numbers will all be on the graph. Now I start moving towards the important number. Is negative 1 greater than or equal to negative 3? Is negative 2 greater than or equal to negative 3? Yes. Is negative 3 greater than or equal to negative 3? Yes, it fits as well because it's greater than or equal to. Sometimes it won't fit if it was just greater than, but it's greater than or equal to. Then you get to negative 4 and you go, oh, no, negative 4 is not greater than or equal to negative 3. So what I've got a graph on here. Take a look at the graph that comes up. I need a line over there in color or in a thick pencil. You're like, well, do I have to use another color? No, you can just go really thick on your graph. You just draw a really thick line to say, I want to indicate all the numbers that are greater than or equal to negative 3. Notice the solid dot. The solid dot's important. We use the solid dot to indicate negative 3 is in, greater than or equal to negative 3. You're like, what happens if it's not what happens if it's not equal to? Well, I'll get to that. I got examples for all of them. But for now, it's just enough to go, okay, if it's included, I go solid dot, and then I go across there on all the numbers that I need. Okay. New example. Absolute value. I did that example just to review greater than or equal to, all that kind of stuff, and get a strategy for absolute value of x greater than 2. We're looking for all the numbers where their absolute value will be greater than 2. I'm going to start with 0. I love starting with 0. Is the absolute value of 0? Oh, hang on. What is the absolute value of 0? How far is 0 from 0? 0. Is that greater than 2? Is 0 bigger than 2? No. So 0 will not be on my graph. Somehow, some way, I got to draw this thing. 0 won't be on the graph. Sort of like negative 7 wasn't on the graph. I won't be filling that in. I won't be highlighting that. How about 1? Is 1, hold on. What's the absolute value of 1? 1. Is that greater than 2? No. How about 2? Absolute value of 2 is 2. Is 2 greater than 2? No, so 2 will not be on the graph. 3, its absolute value is 3. 3 will be on the graph. 4 will be on the graph. 5, 6, 7, 8, 9. And if that was all there was to the story, these wouldn't be that hard. Let's just check some other numbers to be sure. And you can do these questions just like I'm saying, by the way, and just do each individual number until you get your graph. It doesn't take all that long to do. -1. What's the absolute value of -1? How far is -1 from 0? 1. Is that greater than 2? No, so that won't be on the graph. -2. Absolute value of -2. 2. Is that greater than 2? No, that's not greater than 2. -3. Here's the big moment. Absolute value of -3 is 3, and that's greater than 2. So here's all the numbers. Okay, very quickly. I'll see if I can do this right. Here's all the numbers that I want on my graph. Yeah, all those numbers got to be on the graph. And don't include 2 and -2. I'm going to put it up, and then I'm going to ask the question, how do I indicate a point's included, or in this case, not included? Here comes the graph. Do you see how we indicate a point's not included? You just put a little circle, an open circle around it. Technically, the circle's not on the graph, actually. The circle's like a little magnifying glass. It's like saying to everybody, here, look. Do you see? Can you see how I didn't include 2? Yeah, you see? And that's all the circle's doing, is circling the thing, showing people that you didn't include it. When you do want to include it, you fill in the circle and say, yes, include that point there. This is not an easy example. Don't for a second believe it is. So make sure when you go to these homework questions, the homework list on this particular page of absolute value isn't the longest list ever. When you get to it, it's not a huge amount of questions. Take your time on each one. Try not to peek at the solutions. Try not to ask someone else. Really think them through and come up with a strategy of how to deal with absolute value on the number line. And make sure you got it down pat. There's only so many cases. There's only so many things that can happen. It's either going to be a greater than, or it's going to be a less than. You know, so there's only so many possibilities that you can come up with here. So here's the less than one. And I'm going to go through the whole procedure again. Absolute value of x less than or equal to 4. I like starting at 0. Maybe you've got your own strategy. Some people are like, no, when it's a 4, I'm going to start right at 4 and deal with 4 right off the top. You can do that. I like starting at 0. Just deciding if points are on the graph or not. And I'm going to add something to your strategy if you do have trouble with these tonight or this afternoon or whenever. I'm going to get my pen ready in red, and I'm going to start putting dots on the points that I want to include. 0. What's the absolute value of 0? 0. Is that less than or equal to 4? Yeah, so that's going to be on the graph this time. See, with the less than ones, the middle stuff's all on the graph. The greater than ones, the middle stuff's not on the graph. Yeah? Important hint for you really getting good at these. How about 1? What's the absolute value of 1? Is that less than 4? Yeah. How about 2? Is 2 less than 4? 3. 3 is less than 4. Oh, 4. Here's the big moment. Then you got to turn on some extra thinkers, and you go, okay, absolute value of 4 is 4. Is that less than or equal to 4? Yeah, because it's less than or equal to 4. Now, what about 5? 5's out. So over here, this stuff won't be on the graph anymore. So there's my thick dot to say, there's where I stop. Now go the other way. That's the part that people always miss in the test. They forget to deal with the negatives. Because with absolute value, positive and negatives are in this. Slow it down, just in case. You're either right with me and you're like, I got these. Or you're like, I don't know. In which case, here's the slow version of it. Think about the number -1. The absolute value of -1 is positive 1. That is less than or equal to 4, so that'll be on the graph. -2. The absolute value of -2 is positive 2. That's less than 4, so it's on the graph. -3. The absolute value of -3 is positive 3. That's less than 4, so it's on the graph. The big number, -4. The absolute value of -4 is 4, and that's less than or equal to 4. But after you get past that, they're not less than anymore. They get farther away. So there's my graph. From there to there, it comes up on the screen. Just there, that part right there. When studying these, you're like, okay, greater than is outwards, less than's inside. Close. But if you go back to the definition, if you just go back to the definition, and you go back to the definition which says, how far from 0 are you? This is saying we want numbers that are more than 2 away from 0. If you say it that way, it's like really easy. More than 2 away from 0. Here, we want numbers that are less than 4 away from 0. These numbers are less than 4 away from 0. So it's a really deep understanding you get from going back to the original sentence when you're trying these, instead of using your rule, which was positives, positive, negatives, positive. You know what I mean? That rule doesn't have as much power as this does. Okay? Any questions there? Please take these questions very seriously on the homework, the review for the test, and on the practice test I'll provide. You know, like take those seriously and go, don't talk to me, don't give me a hint, let me try them. Then compare your answer to what the actual answer is and see how you did, and improve, improve, improve. Okay, the function y equals absolute value x. What do you think the function will look like? Okay, well, I want to give you more power than just, keep forgetting I'm making videos here, so I'm gonna do this on the screen here. Just going to bring up some graph paper here. There we go. Okay, so here's my strategy. And this is the move, not just in this lesson I'm trying to graph y equals absolute value of x, whatever that's going to look like. Well, this is the strategy you should use in your homework anytime you run into a graph or on a test where you're like, I don't remember how to graph that. Maybe you memorized them, maybe you know them and you just forgot. Maybe you didn't know a particular function, or you're not sure, you're having a brain cramp moment. And the method is the table of values. The table of values is the ultimate power in the universe, in math. If you've got a table of values and a calculator, you can graph anything. It just might take you too long. That's the only difficulty with the method. But on any one question on a test, you're like, oh, hold on. I got this. Build a table of values. Sub in a bunch of x values. How many will you need? Well, I don't know. It depends on the function. For graphing a line, by the time you got 3 points, you should be like, oh, I know what's going on here. For a parabola, it might take 5 or 6 points before you really see what's happening. For absolute value, I don't know. Time will tell. We'll do a bunch of them, and then hopefully by the end of this, we'll be like, okay, that's enough points, or maybe we'll need more points. The function I'm trying to graph is absolute value of x. That's what we want to learn about today. So to find the absolute value of all these points, I just take the x value and find its absolute value. Big moment. This is where you decide whether you're sort of with me in this lesson or not, because this particular step, everything I've said up to there might be difficult, but this particular step is supposed to be easy now in this part of the lesson. What's the absolute value of negative 4? 4. So the absolute value of negative 4 is 4. And the reason I'm graphing the points as I go is some people use this exact strategy to graph things, but they don't necessarily build the table of values. They just sort of sub them in as they go. So that I throw that out there as a possibility too. So absolute value of negative 3? 3. Absolute value of negative 2? 2. Absolute value of negative 1? 1. See, all those negative x values become positive y values. Absolute value of 0. And now the positive ones are easy, right? To find the absolute value of any of these numbers, you just get those numbers right back out. Positive numbers. Yeah. So I get 1, 1, 2, 2, 3, 3, 4, 4. I think I have enough points on this side. Or I can go, I don't need to get any more points here. It's going to be 5, 5, 6, 6, 7, 7, 8, 8, 9. It's just going to keep going like that. There's going to be no difference in the pattern all the way out. Out here, I think I have enough points too. Negative 5 will be 5. Negative 6 will be 6. It'll just keep going like that. Now, did that take long to come up with that graph? Yes and no. No, not really. If you're stuck on a one test question, you could do this to get the graph and you'd be home free. If you have to do that for every function, that I might ask about on a test, if you every time you're building a table of values, you're going to run out of time. But it's your bailout move. It's your emergency graphing move. Your second emergency move when you're doing homework is Desmos. And Desmos will graph y equals absolute value of x. Let me delete this out. And I'll type in y equals, it's in a weird spot, I think, from what I remember. Y equals, and I got to look down here under, well, there's a keyboard down in the bottom corner here. Can you see this little keyboard down here? I'm putting the keyboard up, and I go to functions, and I look through and I try and find absolute value of x. Oh, I don't see it there. Where is it? Oh, oh, they've moved it over. It's over in the main screen now. Absolute value of x. There it is. So there's emergency move number 2. When you're doing your homework, you're like, oh, I forget. Boom. You just bring it up like that. Okay. This won't help you on a test, but table values might. Absolute value. Slide show up on current slide. There it is. Y equals absolute value of x. Any questions on the graph of y equals absolute value of x? You're like, how does this fit in with what you were saying before? Well, positive x's become positive. Negative x's become positive. So it is the same as what we were saying before. Oh, well, hey, we just did domain and range. Why not talk about domain and range? The domain would be any x value. You can find the absolute value of any number. So the fancy way to write that is x element of reals. Range, absolute value gives outputs of only y values greater than or equal to 0. This isn't going away. These two things here, this is not going away. So get your head wrapped around it. I can tell you, by partway through calculus, everybody can do this. It's like tying your shoes. It may seem impossibly hard. I was just teaching my 7-year-old to tie their shoes on the weekend. It's ridiculously hard when you first try to do it, right? It's like riding a bicycle. It's nuts. It's insane trying to learn this stuff. Then at some point, it's like, it's just so obvious, you just do it. So it's not, you got to practice enough to make sure you got it down pat. Do you have any questions about domain and range of absolute value? I can feel it in every lesson I teach in quadmesters. It's the only difference in quadmesters. I can feel it, which is I'm halfway between rushing it so that you can have time to work and making sure I explain it carefully enough. Don't let me away with rushing it. I'm trying to rush it for your benefit so that you can have time to work. But if it's too fast, you just raise your hand, you shake your head, you frown, do something so I don't just keep cruising right along. Transforming the graph of y equals absolute value of x. This is actually a preview to tomorrow morning's lesson on transformations. If you're like, I'm only sort of good at transformations, I don't really remember what you mean by transformations, or what if the 2's here, what if the 2's there, inside, outside, stretch, compression, this is sort of talking about it a little bit. Nothing too crazy yet, but just a few transformations here. We can transform the graph of y equals absolute value x the same way we transformed all the other graphs. For instance, a +3, well, who can remember? +3 outside the function. What does a +3 outside the function do to this thing? Yeah, it makes your starting point up. He's right. It moves everything up 3. When you're doing your homework, and you're like, I don't remember, that's where Desmos is handy, to remind yourself how these things do move around. But here, +3, vertical shift 3 units up. Do you remember? You're supposed to do 1 million of these in grade 11. Like to the point where you're like, I can't take this anymore. Except for COVID, usually this part of the lesson goes pretty quick because everybody's like, yeah, I got it. Transformation's good. So I've just taken the absolute value function. I've moved everything up 3. That's what Brandon said. He said the starting point moved up 3. Well, actually, it's all the points. All the points move up 3. What happens if it's inside the function? This is weird, right? This is not weird. The +3 there, you're like, oh, +3, I get it. Everything's been added 3 to it, so that would move it up. The +4 in the brackets does not work the way you think it would. Because +4 in the brackets, your brain immediately goes, move it to the right. Yeah, +4 to the right. That's not what happens. It goes left. Do you remember this? Inside the function does the opposite of what we would think it would do. There is a reason for that. And the reason is this number is literally being added on to this function, moving the y values up. You're taking y values and you're adding 3 of them. Here, The plus 4 in the left right is with the x. It's not on the opposite side of the equation. See? This plus 3 is not with the y. It's on the other side of the equation. This plus 4 is with the x. So that's why the change. If you really want to get it, the only way to really get it is to build this table of values for this one and build the table of values for this one, and you'll go, oh, I see why it moves it left. Yeah? Oh, by the way, this wasn't cut off. It looks like, oh, well, what happened to the rest of your absolute value? Well, it's only because my screen was 10 by 10. This actually, sort of goes up. Oops. Just so you don't think that something weird is going on here. Let me just get this pen out and say, well, the function actually does this. But I just ran out of graph paper to show it, that's all. More time here? More time? I thought I saw a nod there. No? No nod? Oh, only 2 more slides to go. Yeah? Okay. A tougher one. Okay, here it is. All sorts of stuff going on. This is as tough as transformations actually get. But this one has a major problem. And I'm going to use the uncomfortable silence method here. I'm going to pause and then see if anyone knows what the problem is right off the top. And here's the hint. The problem isn't the number of numbers that are there. There's lots of numbers there. That's difficult, yes. But there's another essential problem with how this one's set up that makes it that I can't even really start the question until I do something vitally important here. Let me tell you about the uncomfortable silence method of teaching. It does 2 things. One is it gives time for people to think. The second thing it does is it puts you in a situation where you're forced to think. Here's how your brain works, actually. It's weird. If I just tell you about something, you've got a reasonable percentage chance of understanding it and knowing it. If I force your brain to go, what's going on here? I don't understand. And you're freaking out, and then I tell you the answer, your brain goes, oh, that's important. Because your brain remembers the feeling of terror that you're like, I don't remember what he's talking about. Then when I attached on there, it goes boom. And then maybe you'll remember it come test time. Yeah? So I'm really up to something. I'm not just trying to make you feel uncomfortable. I'm trying to make your brain go, tell me. What's going on? Because apparently there's something about this particular example that you're supposed to know to be able to handle. And if you don't know how to handle that, it's going to be a problem. What's the difficulty with the way this function is set up? You need all that time to try to think. What's the difficulty here? Common factor. Yeah, it's got to be common factor. For these functions for the transformations to all work the way we've understood them, you can't have an x with a coefficient like that. It's got to be common factor. If you want, the x has to be all by itself. Once it's like this, then it's just a matter of listing off those transformations. And I'm going to list them all off here. And if my list here makes you go, okay, I remember all that stuff now, then great. If I make this list here and you go, oh, you lost me. I don't remember any of those at all. Don't worry. I'm doing the whole lesson on it tomorrow morning. Just try and survive this lesson or this homework by, patching together your knowledge of transformations. Here's the transformations that are there. There's a vertical reflection right there. This thing's been flipped this way. Might remember that from parabolas. When parabolas was when there's a negative out front, this thing vertically reflected. It's been vertically stretched by factor 2. That's that 2 right there out front. Then it's been horizontally compressed by factor 1/2. The number inside the function does the opposite of what you think. You think it's going to be a stretch by factor 2, but it's actually a compression by factor 2. And finally, it's been moved right 3 units. Now, I'm going to say something that I think is going to make a whole bunch of people suddenly go, oh, yeah. It's not, I don't teach grade 11, so I don't teach this stuff. But I think most of you will know it. Okay, you build a table of values, and you do, it's not SP, is it SPDF? What are the letters? You know what I'm talking about? Stretches, reflections. SRT. Yeah, that's what it is. Does this ring a bell? No, you don't. Oh, hey, I'll show you. I'm going to show you SRT like crazy. Because some of you grade 11 people know it. I never use SRT. But you can use SRT to get all these points. It completely loses all the fun of transformations and just gets the answer. Yeah? I'll do it in just a second. I'll show you the way I sort of do them first. The way I would do this is I would go, okay, start with the absolute value function. Don't bother drawing the lines. Just get some points on there to get you started. And then I do all the transformations at once and get the final points, right? So I'm going to take this point, 0, 0, and I'm going to do all these transformations on it. Vertical reflection, that doesn't do anything to it. Vertical stretch factor 2, it's at 0. If I stretch it by factor 2, nothing happens to it. Horizontal compression factor half, that doesn't do anything to it, and then it goes right 3, and I end up with that point right there. Ooh, I'm going to do the new points in a new color, okay? Pointer options, ink color, we'll put them in blue. And you don't have to do very many points before you get the shape of the new graph. Didn't follow me? I'm going to do it. I'm just going to do it again, again, and again, and again. Number 1, vertical reflection. So it comes down to here, down to -1. Vertical stretch factor 2, so I double its y values, goes to 2. Horizontal compression factor 1/2, the x value becomes half, and then 3 units to the right, 1, 2, 3, I get this point right here. At that moment, there's only 3 types of people. Are like, oh, I like this. You just take each individual point and you move it around. There's some people like, I don't know what you're talking about. And then there's some people like, can you just build a table of values and do SRT, please? That's what I know how to do, right? I'm going to do all. I'm going to do all that stuff, yeah? I'm going to explain this more carefully so that maybe you become this type of person. I'm not trying to convince you. Then I'm going to do SRT on this thing and graph the whole thing. I think I got enough room up here to do SRT. One more point, carefully, slowly, carefully. I'm going to take about this point right here. I'm going to vertically reflect it. So instead of it being 2, it vertically reflects down to -2. Vertical stretch factor 2, that means I double the y values, down to -4. Horizontal compression factor 1/2, I half the x values, and then move it 3 units to the right. 1, 2, 3, and I get this point right here. On a scale of 1 to 10, if you were like a 1, going, I don't see what you're doing at all there. Hopefully on that one, you're like, oh, I'm a little better now. I sort of followed what you're doing there. I'll do one more. What did I do? 2, 2? Now I'm going to do 3, 3. All the things to 3, 3. Vertical reflect in the x-axis, so it goes down to y value -3. Vertical stretch factor 2, it goes down to 6, or it expands down to 6. Compression factor 1/2, the x value is half, and then move right 3, 1, 2, 3. And after a few of those points, you're like, oh, I see what's happening here. And then you do it with all the points over here, and away you go. Now, you're like, oh, I sort of am liking this. I just got to work on it a little bit. Great. Or you're like, no, no, I don't like this at all. What else you got? Yeah? Here's what else I got. I need a different color. Ink color white. Okay? I'm going to make a little table of values. And I'm going to make just a mini version of it, which you can do as many points as you want using this method. Okay? And I'm going to get some points on the original absolute value graph. And here's just 5 points. -2, -1, 0, 1, 2. You could literally do the whole question like this. Like, I don't even remember what absolute value is. I don't really remember every little step of the transformations. Here's how I'm going to handle it. Make a table of values. Find the absolute value of each of the points. And then redo all the points, but just do what it tells you to do here. It says vertical reflection in the x-axis. That means positive y values become negative, negative y values become positive. So these become -2, -1, 0, -1, -2. You just make the whole list here. This is SRT. I'm doing stretches and reflections and transformations here. Yeah? First I did the reflection. Now stretches. Vertical stretch factor 2. That means double all the y values. Is this coming back to anyone now that I'm doing this? From grade 11 a little bit? The SRT thing? No. COVID? COVID people? Or did you have a semester 1 or semester 2? You had it during COVID, yeah. So it might have got glossed over, okay? So you got to choose one of my 2 methods for transformations. When do you have to have this down pat by? I'm doing a whole nother lesson on it tomorrow. Yeah, so this is like intro to transformations for those of you who COVIDed this thing. What about people who didn't have COVID? Where's people who had it semester 1? Are you remembering this SRT? They're nodding a lot more. See, there's the problem with COVID and online learning right there. You're thinking, you know what? Maybe I'll take math online next quad. Are you nuts? Yeah? You got to see all these little tricks. That's why you come here. Slow it down. You haven't seen it before, so slow it down. Horizontal compression factor half. It means all the x values become half of what they were. These become half. That's -1, that's -0.5, that's 0, that's 0.5, and that's 1. And then 3 units right means add 3 to the x values. 2, 2.5, 3, 3.5, and 4. And then you graph those points. See, the table of values walks you through getting all your new points. 3, 0, 3.5, comma, -2. They're all right there for you. More on that tomorrow, okay? So manage your way the best you can. Better yet, find out when you do this homework how good or bad you are at this. And if you're like hopelessly bad at it, then you got to let me know that as I teach transformations tomorrow, okay? But I'm not trying to rush through it. What questions do you have? Would you like me to do another one? Or it's like, no, it's not bad. I'll give it a try. One more, she says. Okay, I'm going to pause the video. Oh, no, you maybe want it on the video. I'll go back to, I'll make up a whole new one. Using absolute value for now, okay? Keep those for now. Over to here. New graph. There we go. I'll give you one like this. Say, here, graph this thing. In fact, on the test, the first page is a couple of questions like this. I might not choose absolute value. I might choose x squared, or I might choose exponential, or I might choose any number of other graphs. Like, which ones? Tell me which ones. I'm going to. Later today, last PowerPoint of the day, I totally review which functions you're supposed to know at this point. All right? So don't panic about that until I talk about these. Any one of these, you can get the table of values out and take care of it. So, in this particular moment, and maybe we've got to talk about panic at this point. Two great stories. The first story is about my kids owning bunnies. They were convinced that this was the perfect pet. In some ways, bunnies are the perfect pet. They stay in their cage. You don't have to worry about them. You throw enough food down, they don't overeat and kill themselves, so that's good. That's a good feature in a pet, right? Now, I used to come down at the same time every day and feed the pets. Right when I got home from school, I'd come down and feed the bunnies. I'd come in the door, I walk in slowly, and the bunnies can't even help themselves. It's ingrained in a bunny to run away from noises. They can't help it. They know who I am. They'd be looking at me as I walked across the room. As soon as I came in the door, they started running, and they'd bang themselves into the side of the cage trying to run away. Smash into the side of the cage. Panic, no thinking available. Yeah? You think that's crazy. It's not crazy. So one time when I was 13 years old enough to think that I knew everything. And you go through this phase in your life from about 12, different people it's different. Somewhere between 12 and 25, you decide you know everything. And then by about 26, you figure out, oh, I don't know anything, as it turns out. I was wrong about all that. Yeah, and then you learn what it takes to be an adult. Fine. So I was 13, convinced I knew everything. And the washing machine, my bedroom was beside the laundry room. The washing machine started freaking out. It made this loud squealing noise. I stuck my head out the door and I'm like this, and it's bouncing around the room. That's what happens when you don't load a washing machine with, don't do it, but if you put a big towel in with a couple of shirts, the towel will just grab and it'll just start, it's nuts. You got to balance the load. Anyways, I put my head around the corner like this, and then complete and utter panic. Now, I'm a pretty smart kid at 13. There's nothing in a by the way, washing machines don't blow up. There's nothing in a washing machine that makes it blow up. At worst, it might go little fire or something like that coming out the top. It's not going to explode. There's nothing in a washing machine to explode. Yeah, it's mostly air. Yeah? But here's what I did. Swear, this is exactly what happened. I ran across the room, across the top of my bed, to the wall in my room, and kept running. My head was banging into the wall as I ran away from this scary noise. Meanwhile, I could see out my bedroom door, and I finally calm down enough to look back. My dad comes walking through the laundry room, walking, looks at the washing machine, and turns it off. Looks at me like, and I'm standing in my bed, looking against the wall like this, looks at me like, what the heck is wrong with you? Learned a lot that day about panic, though, right? When you panic, you're done. What's a... Go turn it off. Pull the cord out of the wall. Like any number of things. This thing's not going to explode. But panic turns your brains off. We're actually designed by that. Our bodies as animals were designed to, when it's time to panic, turn your brain off and run. Stop thinking, run away. So if you're feeling panic in the middle of an advanced functions course, that's not going to help you at all. Yeah? You can't let that panic take over. I'm going to fail this course. I'm not going to university. My parents are killing me. What? None of that's going to happen. None of that's going to happen. Right? Relax. Take a deep breath. Look up a YouTube video. Try it again. It's not impossible. It's not impossible, or we wouldn't be teaching it in grade 12. Totally missed all this stuff in grade 11? Don't care. We'll get it figured out. It's not impossible. It was in grade 11. It can't be impossible. It was in grade 11. Right? We'll get it worked out. Big thing, though, you got to let me know. You can't just let me cruise along. Like, this happened with AP Calc in the last round. They let me cruise through a lesson, came back the next day and said, Mr. Todd, we didn't understand. I'm like, well, that doesn't... Like, unless I have a time machine, I can't fix yesterday. You got right now. You see, I'll pause. I don't care. I'm not rushing it. Got to let me know. Comparing to my dad's a bad move, though, because we had a skunk problem. This is a true story, too. I come out and I said, Dad, something's digging in the garbage. My dad still lives with us, one of those divided houses, 74 years old. I say, Dad, there's something digging in the garbage there. He says, oh, I'll look into it. Comes back and says, it's a skunk. There's a skunk digging in the garbage. I'm like, oh. So I say, what are we going to do about it? Meaning, what's he going to do about it? Here's what he did. All true. He got a live trap. It's a trap that just sort of sits with its ends up like this. It's a cage. It's about 3 times as long as this. Puts stuff in, he puts some lettuce inside it, and he puts it beside the garage. Skunk walks in, triggers the trap, and all the trap does is close the door. Now the skunk can't get out. I come out next morning to take the kids out of the bus and go, oh, skunk in the trap. Do you see the problem with this? Now what? So I, like a man would, go over to my dad. Hey, yo, you got a skunk out there. Notice the difference in the phrasing. Not, how are we going to deal with this? I switched over to, you have a skunk out there. He's like, huh. Goes out and looks at it. Yeah, he says. You're not going to believe the next part. Goes over, takes a blanket, walks over, drops the blanket on the thing, picks up the cage, walks over and puts it in the back of his truck. I'm like, what's going on here? How can I be 47 years old and be so far from manhood that my dad is showing me up here with a skunk? Puts a skunk in the back, puts it in the back, drives off. I'm standing there flabbergasted going, what just happened here? So maybe me comparing to him as far as panic level, when he's carrying skunks around, it's being too hard on myself, but wow. Did I read that right? All of a sudden there was panic in the room, was there? About transformations from some of you. Let the panic go. Let's do another example. And then tonight you can look up transformations if you're really confused. Actually, no, you won't tonight. Tomorrow night. If by this time tomorrow, transformations aren't a whole lot better, then you can go panic online if you want. Let's do another example. That's all going to be on the video. You can share that with your friends. First step when you're doing transformation. Step 1, identify what the base function is. Forget the 3s, the 2s, the 1s, the 4s, the negatives. Don't even care. All I really care about is y equals absolute value of x. And we're going to call that tomorrow, we'll call that the base or the parent function. That's what we'll call it tomorrow. And at that point, you might be stuck with your table of values. You saw me do one earlier. Hopefully you're not stuck with table of values by the time test comes in. But if you are stuck with table of values, you build a table of values, and you get yourself a nice table of values of the function. I'm going to teach both methods at once. I'm going to teach SRT, which is what most grade 11 teachers teach when they're in class and can go through all the steps with you. And I'm going to teach my method, which is just take the individual points. I'm going to do both at the exact same time. If you're doing SRT, you build yourself a nice table of values. If you're doing my method, you just graph a quick version of the absolute value function. You know, you don't need all the points. You need enough points that shows what's going on here. You don't believe me? You'll see at the end. So SRT people will do this. They'll look at this thing and they'll write down all the transformations. If you're not sure where I'm getting each of these transformations from, that's what's going to come tomorrow, where each come. The number out front is the vertical stretch. I'm going to put vertical stretch times 3, and I just want to put in brackets, I'm going to circle, I'm going to put vertical stretch has to do with the y values. Next, -2 inside means horizontal translation. -2 means right 2. Right is the x values. And then finally, this +1 out here means vertical translation up 1. And that, again, has to do with y values. Hopefully, up is a good enough word that you're like, oh, up. That'll be y values. Now, if you're doing SRT, it's called SRT because it's what it gives you directions on what to do in what order. It says do stretches first. So I want to stretch the y values by factor 3. That just means multiply all the y values by factor 3. So I get a 6. There's a mistake on my table of values. Do you see it? I was too busy talking while I was building it. I want that in red just because I'm uptight. There we go. There's the table of values for absolute value. Vertical stretch by factor 3 means stretch the y values by factor 3. Triple them. So I get 6, 3, 0, 3, 6. SRT says do your stretches first. Then it says do your reflections. It actually doesn't matter which one of these you do first, whether you do reflections or stretches first. But just for memory tool, you do stretches, reflections. This one doesn't have any reflections. Then it says do your translations. So I'm going to translate the x values right 2. Right 2, this will become a 0, a 1, 2, 3, and a 4. And then it says vertical translation, move all your y values up 1. I get a 7, a 4, a 1, a 4, and a 7. And you graph those points. I'll come back to that in just a second. Then I'll do my method for a while and then finish off this method at the end. My method is I do all this stuff all together to each individual point. Those are in red, I'm going to go in blue. Take this point, vertical stretch factor 3. I multiply the y value by 3. 0 times 3 is 3. Then I take it and I go right 2, up 1. I'll take this one. Vertical stretch factor 3. Right 2, up 1. Take this one. Vertical stretch factor 3. Right 2, up 1. I only did those ones fast to show you how fast my method can be. No big table, no writing these all out, and all that kind of stuff. I just grab the individual points and take them where they got to go. You're like, yeah, okay. I sort of like how fast you did that, but I got to be able to do it that fast for it to matter. So I'm going to slow it down. I'm going to take this point right here. I'm going to vertically stretch it by factor 3, which means multiply the y value by 3. It goes up to 3. Then I got to take that thing and go right 2, up 1. See how fast the right 2 up 1 is? The translations go super fast. They don't really go super fast in the table of values. I'm not against the table of values. I'm not. Do SRT if you like it. One more time, very slowly. Take this thing, vertically stretch it factor 3. So I triple the y value to 6, right 2, up 1. Back to the SRT method. You graph the points. 2, 1. 3, 4. 4, 7. 1, 4. 0, 7. You'd have enough that you go, okay, I see what's going on here. You get out your ruler, straight line, glue, and you go, oh yeah, there it is. tell me about your questions. Which part do you want to talk about more, about transformations? Is it good? No, maybe it's not good. Maybe good's not the goal here. Is it okay enough that you're like, well, yeah, I can take a shot at that in the homework. I sort of got the feel for that. Okay. Either method will do. This will be all in the video, so you can go back and slow it down to whatever speed you need to get transformations down pat. Knowing you're coming right back in tomorrow for another lesson on transformations. Where was that? I was doing absolute value, right? Was I here? We got to here, and I said, how about another one? You said yes. I went and did another one. We good? Got to know that about me all the way through, right? From here to wherever. Feels like I'm rushing. The only reason I'll rush in this class, I used to teach advanced functions bell to bell virtually every day. Yeah, 75-minute lessons every time. We don't have that option here because you want some time to do some work in class, so you don't have hours and hours of homework. But anytime you want, you just go, whoa, 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 whoa. No good. Go again. I'll go again. I've got more than enough energy to do it. How many more slides here? Oh, one last slide, which actually, some things I'm like, oh, this is really important. This is important, but it'll be a developing idea. I got to do a little bit of it today, a little bit of it in 1-07, and then finish it off in 1-08. So this is just planting an idea. Don't get too wound up about this. It's just planting the idea. There's another way to write absolute value of x. Absolute value of x can be easy. It can be the easiest function on the list, and it can be the hardest function on the list, depending on what you got to do. Another way to write absolute value of x is to go, listen, this is just two straight lines. That's all we're talking about. Instead of this being complicated with an absolute value symbol, couldn't I just say, okay, graph a line over here and graph a line over there? And that's true. When you want to deal with absolute value algebraically, it's easier to deal with in two pieces and saying, okay, one part is the line y equals x. Up here, let me write that on there. This is y equals x. This is the line y equals x. Isn't that simple? We want to do the graph y equals x over there, and we want to do the graph y equals negative x over here. There's just two lines there, and that's what this is saying. You can graph y equals x when the x values are greater than 0. You can draw y equals negative x when x is less than 0. If you're like, okay, this notation's really throwing me off. So you can do a squirrely bracket, and then you can do different functions within the same function. And the answer is a big yes. And you see the lesson piecewise functions down there? Is my laser working? I can't even see that far. I'm burning someone's eyes out. There's my laser coming down. Right there. Piecewise functions. I'll talk more about this. So this is just planting a seed. Don't worry too much about this slide for now. It's just like, be aware, absolute value sometimes is better written as two different pieces put together. Okay? What do you really got to worry about in the homework for absolute value? The slides before that. There's not much of this in the homework.